So, as we're reviewing for the quiz, this review will be very similar to the quiz that we're going to be taking tomorrow. So check it out. Number 1, 2, and 3. This section is titled Medians and Centroids. So it tells you that C is a centroid. Okay, so that means if C is a centroid, BG is a median. So that means this is a midpoint. So we know those are the same. And then we know that F would be a midpoint. So those are the same. And we know that E would be a midpoint. So those would be the same. All right. So if CG is 3, what's the length of BC? So we think of CG and BC. I like to draw my segment. One of them is shorter than the other. And this is GCB. Notice the way I labeled it, because CG is the shorter part, and then BC is the longer part. So I kind of flipped it around. You can draw it the other way, it doesn't matter. But let's label it CG equals 3. So what's the length of BC? Now, if you remember, GC is the 1/3 section, CB will be the 2/3 section, and if you know the small part, to get the big part, you're just going to multiply by 2. You double it, because to get from 1 to 2, you just double, right? So times 2. 3 times 2 is 6. Now, if I was asking for the whole thing, that would be 9. But we're not asking for the whole thing, we're asking for BC, and we already labeled it as 6. All right, so remember, if you've got the small part, all you got to do is double it to get the big part, add them together if you need to. If you know the big part, you have to divide it by 2 to get the small part, add them together if you need to. Let's see the next one, number 2. If CF equals 6, okay, so CF is from here to here. What is the length of AF and AC? So CF equals 6. Let's go ahead and draw a picture again. So the small part is F, C, and A. So CF is 6. So once again, I'm given the small part. What is the length of AF and AC? Now we know we can get the AC easily, just like the one we just did. To get from the 1/3 part to the 2/3 part, we're just going to go from small to big. We're going to multiply by 2. So that means AC is going to be 12. That was easy. What if I'm supposed to get the whole thing? Well, I add them up. 6 plus 12 is 18. From A to F, all the way across. To get all the way across, you got to add them up. 6 plus 12 is 18. Okay? And then 3, if BG equals 33, from B to G, all the way across is 33. Sorry about that. From B to G, this is 33. So G, C, B. All these seem to be written backwards. If you flipped it around, it's fine. But BG is 33. The whole thing. What is the length of BC? So BC. Now, which fraction is BC? Well, remember, the small one's 1/3. The big one is 2/3. So I'm going to take that whole thing, 33, and just multiply it by the fraction I'm looking for. BC is 2/3. So 33 times 2/3. If I plug that into my calculator, I'm going to get 22. All right, so CG equals 22. All right, and moving on to number 4 and 5. So on 4 and 5, it tells you something important in the instructions. We're talking about angle bisectors and incenter. P is an incenter. Okay, so this is PB equals 5. From P to B is 5. Now, since I know P is an incenter, that means each of these little angles is bisected. So these blue lines are bisectors, bisectors, bisectors. And if P is an incenter, like it says it is, that means from the incenter to the edge, making a right angle, these little red segments are all going to be congruent. So I'm going to put little tick marks on these, because I know from what I learned about an incenter, those are congruent. So if PB is 5, take a wild guess. What's PA going to be? Well, we just put tick marks, so PA is also going to be 5. Easy? I hope so. Okay? So again, if you know one of these little segments from the in-center to the edge, you know the other segments from the in-center to the edge. They're all equidistant. They're all equal, and they're all congruent, right? Equal in their measurement. Now, we talked about angle bisectors. So here's another easy one. PUC, this little angle right here, is 13. What is PUD? PUD. Well, remember, this blue line is an angle bisector, so PUD is going to equal PUC. These are equal angles. So if they're equal angles, and this one's 13, PUD is also going to be 13, right? So PUD is 13 degrees. Because in-center means angle bisector. Angle bisector means these two halves are equal. No big deal, right? And then number 6. Okay. Mid-segment. We said, and we know, that from a midpoint to a midpoint, okay, the mid-segment is half of the parallel side. So again, from here to here is half of this parallel side. So if the bigger outside segment is 24, and we know the mid-segment is half of that, then we know 24 divided by 2 gives me x, right? So 24 over 2 equals x, and we know that's going to be 12, right? Do you see how that makes sense? Mid-segment is half of the parallel side. And we know it's the mid-segment because that's a midpoint because of these tick marks. Okay? Now, what if you have something like number 7? Now, it's not just numbers, so it's not going to be as easy to do. I know my mid-segment from this midpoint to this midpoint, 5x is half of the parallel side, 70. So, here's what I'm going to do. I'm going to take my smaller segment and multiply it by 2. Because isn't half times 2 equal to a whole? It is. So 2 times the smaller one equals the bigger one. Then all we have to do is solve this algebraically. 2 times 5x is 10x. That equals 70. And our last step to get rid of that 10 is to divide by 10. And we get for x 7. And then on the back side, altitudes and orthocenters. We did this recently as well. Okay. What we're going to do is find the orthocenter. First thing we got to do is plot these points. 0, -1. So that's U. W is 6, -1. So I can put that one already. And then V is 2, -5. So let's scroll down here. 2. Okay, 1, 2, 3, 4. Okay, 2, -5. That's V. Now, for all these, I'm supposed to find the orthocenter. All right? So let me connect these, and we'll do it the way we did on our notes. So from U to V, V to W. Sorry for that interruption. All right, so we're going to find these slopes, UV. Okay, so we're doing slopes over here, right? Just like our notes. So the slopes of UV, so that goes down 1, 2, 3, 4 over 2. So that's -4 over 2, which is equal to -2 over 1. VW is up 1, 2, 3, 4, right 1, 2, 3, 4. That's 4 over 4, which is equal to 1 over 1. And then UW is totally flat, so that's going to be 0. Now you'll remember, not only do you find the slopes, but you want to find the perpendicular slopes. That way we can make these altitudes. That's how you make an orthocenter. So perpendicular means opposite reciprocal. What's the opposite reciprocal of negative? 2 over 1. Positive, 1 over 2. At the other vertex besides U and V, W. The opposite reciprocal of positive 1 over 1 is negative 1 over 1. At, besides VW, we have U. And the opposite reciprocal of 0 is undefined, a vertical line at, and then UW, the third letter would be V. So, with that said, at W, we're using a slope of 1/2, so it's going to go like this, because up 1, right 2, or down 1, left 2. So that's how I got these 2 points. Down to the left is the same thing as up and to the right. So I'm going to make my altitude here. It goes from here through there, and we know that it makes a right angle. And then starting at U, it goes, negative 1 over 1, down 1, right 1, down 1, right 1, down 1, right 1. And so once again, we can make our altitude. And we know it makes a right angle right there. And then last but not least, we've got our, from V, undefined means straight up and down. So all the way through there. And we'll use our straight line to make that. All that's great. It makes a right angle like we said it would. And do you see the orthocenter right where they all cross, right there, at 2, negative 3. So the orthocenter is at 2, negative 3. And that's how you're going to do it on your quiz.